Alright, day 16. Now before continuing with this animation stuff, I have some ideas about how to make the custom blend work, and I want to try them. So we're back. Alright, we're back here. Let's see. Okay, well, custom blend means custom pixel shader. So, yeah, alright. And it also means that I need to create a debug texture. Again. Let's see, whatever the atlas is here. Yeah, here's the atlas. Okay. Well, I mean, we do all of this, and then I'm just gonna overwrite the atlas again. I can do temp pixels, U32 temp pixels is that array. 0, 0, 0, 0, 0. What is this again? 5, right? It's 5 and 4. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so 5 and 4. Atlas width is 5. Atlas height is 4. Atlas pixels is temp pixels. Okay, and now just fill them in. So this one's red. RGBA backwards. Red. Blue. RGB. Green. RGB. And like whatever that is, yellow. Yeah, that'll do. Now, when it comes to rectangles that we're pushing, yeah, let's turn most of them. Let's turn all of them off, actually. Let's push one sprite. One sprite. Okay, so what okay, well now, I mean, well, actually I don't have to do this way. Don't have to do it this way. Because, here we go, alright. I can just push my debug sprite right here. Yeah, there we go. Sprite, rect, text, and atlas. I can just replace this. Yeah, so rect, top left, dim. I mean, let's start with 0, 0. Well, should I start with 0, 0? No. I mean, we're looking that this is. Yeah, let's start with, I guess, 1, 1. Yeah, just this whole thing, maybe. Just 1, 1. 3, 3. I mean, 1, 1 and dimensions to 2, 2. So all of them are just that. I mean, I don't know what that's gonna do. Yeah, okay, I think that did the right thing, after all. Of course, we're throwing like many of them in different locations, so yeah, we kind of want to reduce the size of the window, right? Ideally. So let's do that. And what's the MIP level? The MIP level is 1, I think? Okay, let's reduce the size of the window. So we're drawing 1-to-1. Yeah, so custom blend will not work for 1-to-1, so that's a limitation. But we can just always make sure that it's greater than 1-to-1. Anyway, where is this? Okay, here. Yeah, window width and height are changed in here, and then used in a bunch of places. So I can just overwrite it. Let's say width is 5 and height is 4 to match this. I mean, really, I just want it to be small. Although, how small do we... Okay, actually, do we need to override the window? Maybe we don't. Maybe this is enough. Zoom it. Where's my... Oh my god. The taskbar. This taskbar just never works. Zoom it. Let's launch it and zoom in. Okay, so that's the atlas, right? And it's being bilinearly blended. And this looks fine, kind of. I mean, we didn't include the transparent border into the... Yeah, that's why it's flicking in and out of existence, kind of suddenly, like boom. Yeah, you would have to include the transparent border in order for that to not happen. But with custom blend, I think we don't actually have to do that. Anyway, let's do the custom blend again. Okay, so in addition to UV, we're also gonna have UV left, UV right, UV top, and UV bottom. Left, right, top, bottom. And now I just need to compute them in Sprite. Although, man, we kind of do want separate pixel shaders and vertex shaders. Because now we have to do this to prevent warnings. I guess let's put a to-do here. Separate pixel shaders if the custom blend actually works. Okay. But for now, it'll just be the same. Okay, so we're getting this input. Yeah, so in the sprite, we actually need to work this out. Left, right, top, bottom. Okay, So this is like half, like in order to work out UV left, this would be this UV plus half, because this UV is like the center. Left would be minus, right? Minus half pixel in UV space. It's that. And right would be plus, and top would be minus. On top would be minus, yeah. And this would be plus, and of course top and bottom are y, and left and right are x. Okay, so now I just need to work this out. So what's half pixel in UV space? Float to okay, well, going back here, so we have this like screen pixel, and we kind of want to know, well, given the screen pixel, if you go halfway here, what's that in UV? Essentially, what's in this space? What's that in UV space? Same here on the Y. So, well, if you just take 0.5, I guess, well, let's make it explicitly 0.5. If you take the 0.5s and just divide them by the size of the object in screen pixels, divided by dim and screen space. So we have dimensions in clip space. Dimension in screen space would be, I mean, well, right now we're kind of assuming that okay, sprite scale multiplier set to 1. Yeah, so that thing is set to 1, and it depends on sprite's MIP, which we are defaulting that to 1, I think, right? Yeah, because sprites are just initially, yeah, it's defaulted to the default 0. Okay, so that's gonna be 1, so this is camera half, so we're assuming it's 1 to 1 here. And I suppose instead of passing the camera half span, it's a good idea to just pass in the scale multiplier thing. Which right now is 1. Okay, world unit dimension is the atlas dimension. Okay, so this is not actually gonna be true anymore. World unit dimensions are just that, just text and atlas dim. Because the source pixels at MIP1, those are the world units. So that's world unit dimension. Offset for center is world unit dimension by 2 minus the offset that was passed in, which is in world units. Then we do some flipping, and then we go in here and say this is the offset position, this is position in camera space. This is position in clip space, which is correct. This is the dimension in clip space, so that would be the dimension of... Okay, so this is actually different now. So this is essentially dimensions in screen space, in pixels. It's like float to screen dimensions, like we need to work those out somehow. Screen dimensions are these dimensions multiplied by the scale multiplier thing. Those are the screen dimensions. And these are the world unit dimensions. Yeah, that's the difference, right? Screen dimensions, world unit, now, so this scale in UV, wait, no, not scale in UV, dimensions in clip space. Would be the dimensions, yeah, would be dimensions on screen multiplied by 2 because that's just the range of the clip space. Screen dimensions divided by window dimensions, so that scales from 0 to 1, multiplied by 2 to scale it from minus 1 to 1, essentially. Okay. Okay, scale in clip space is that divided by 2, pretty much. Position in UV, scale in UV, so that's all fine. Yeah, I think this all still works. Now half pixel in UV, okay, so it's 0.5 divided by, well, if we just divide by screen dimensions, so like if this is if this was the object, then we took this 0.5 divided by screen dimensions, so we know how deep we are into the object. Now if we multiply that by, well, we multiply it by the text and atlas dim, right? So scale in UV. So we need to multiply it by that and then divide by the texture atlas dim. To get that, yeah, to get that half pixel in UV space specifically. All right. Yeah. Does that compile? That compiles. Now in the pixel shader, so this is where the blend is actually going to happen. Now before we get there though, let's sprite scale multiplier. Okay, so let's just set it to 2 and look at the vertex shader specifically. Yeah, and the other thing is we actually want nearest sampling. Yeah, for sprites we want nearest sampling. So that, okay. Render doc. Yeah, okay, so there we have our yeah, that's 2 pixels, that's 2 pixels, 2 pixels. Everything's 2 pixels. Let's go into the mesh viewer, I guess, and step through some of these. So that is sprite. Okay, so camera half span at 640, yeah, that seems about right. Screen dimensions should be like 4:4, yeah, the world unit dimensions is 2:2. Offset, whatever, yeah, position on camera, so move it around. Okay, this vertex, UVs, this UV, mirror maybe, this UV, okay, half pixel in UV space, 0.05. 0.05. So this is UV. So half pixel, that's referring to the source pixel, right? So our source pixel is actually twice that. So that is like the source pixel grid. And it's like this, essentially. It's on top of the notation, and it should be aligned. So essentially we are asking like how big is this distance specifically. So we know that this is this is UV space. So this is 0.2, this whole pixel is 0.2. So one screen pixel would actually be 0.01, so this is 0.1, and half of that is 0.05. So that seems correct. Okay, so now we move the UVs around, so it'll be interpolated. Okay, so the vertex shader I think is working. Now we go in. Okay, pixel shader. Yeah, so we're gonna have to split those. So this is the simple one, but the one that we actually want is not this. It's different. The one that we actually want is this: left, right, top, bottom, left, right, top, bottom. Okay, so we sample these for, well, actually, before we even get there. So given our source pixel, right, we really have essentially 4 cases. Like, this is the case where it's fully in. This is the case where we need to blend top and bottom. This is the case where we need to blend left and right. And this is the case where we need to blend all 4 of them. So these are the 4 cases. Really. Okay, and what if I just do them all like separately? Okay, we want what? We want the texel coordinate. Like for the whole atlas, we want the texel coordinate for all of the edges. So float texel left is input UV left times atlas dim x. Tex right, UV right. Then we've got float text top is input UV top times atlas dim y, and this is bottom, UV bottom times atlas dim y. Okay, so that gives us the texel coordinate. Now float left. Okay, so we want left ceiling text left. We want left ceiling and right floor. Left ceiling, right floor, top ceiling, and bottom floor. Bottom floor. Okay, now given that we have these. Okay, so in this case, left ceiling and right floor will be different. But in this case, left ceiling and right floor should be the same. Okay, so and this basically indicates if we need to blend or not. H blend is left ceiling equals right floor. V blend is top ceiling equals bottom floor. And the four cases are if H blend and V blend, that's one, else H blend, okay, else if H blend, else if V blend, and then else, okay. So if we need to blend both, that's this case. If we need to blend both, then we sample all four corners. We work out the blend factor. Float blend factor. Actually, do we? So we have this in Texel space. So if we multiply by Atlas dimension, that gives us the Texel coordinate, which is like 1.7, let's say. And if you have ceiling and floor, that should give you 0.3, which from here to here, how much of a... Okay, so this is not quite the blend factor. But it's blend factor in Texel space. Like, you know what proportion of the Texel you are in, but you need to know what proportion of the pixel, so which is different. But we have that scale multiplier, so we just divide it by the scale multiplier, right? And that will give us what we want. Because we know how much bigger a source pixel, source pixel is than a screen pixel. Okay, so blend factor, H blend factor is left ceiling minus left. Well, text left. So it's that. I guess I can just do blend factor. Float 2 blend factor is float 2. So that's that, and both of these will be multiplied by... Well, actually, will they? Will they just be multiplied by one factor? If we're over here, then this is going to be something like 0.5, but the blend factor is clearly like too close to 1. So yes, all the pixels is... By looking at one pixel here, and it's square, and we've already multiplied by Atlas dimensions, so we're looking at... Yeah, I think we could just multiply. Right scale multiplier, right? Left ceiling minus text left, and this is... And the top blend factor will be top ceiling minus top. Text top. Like that. Okay, so if that's the blend factor, well then... Well then we just blend the top text color left and text color right. We just lerp it. from left to right by blend factor x. Now lerp is a built-in, okay. Wait, what's the interface to that though? What's the interface? Oh my god. HLSL lerp. XYS. First, second, yeah, okay, I think I got it right. Okay, so it lerp that, so this is float for text color top. Okay, this isn't even, okay, this doesn't make sense, hold on. Text color top left, this is corners. Color top right. Text color bottom left. Text color bottom right. There. Float to left, input UV top. Oh yeah, these are not float twos. It's just floats. Okay, so this is UVX. This is UVY. That's float to left top. Top right is float to right. Input UV top. This is float to bottom left. Input UV left bottom. And this is float to input UV right bottom. Okay, bottom right, that's bottom right, bottom left, top right, top left. So top would be top left and top right. And bottom would be bottom left and bottom right. The result. Yes, result. Set it to lerp from top to bottom by the blend factor y. Okay, so that's that case. H blend should be, I mean, it's kind of similar, but we don't do, that's this case, like we don't do, we only need to sample, let's say, the top left and bottom left. And bottom, and top left and top right. So blend factor, there's only one blend factor, which is just that. Well, I mean, yeah, I think as long as the aspect ratio of the textured object and the actual texture are the same, then we could just multiply here. We don't need to do anything else because they're the same, like they're square. if one set of pixels square, the other one is also square. Top left, top right, there's the blend factor and text color. I mean, it's really even, like in this case, top left and bottom left should really be the same. Let's just call it left and right. Blend, left, right, blend factor, and then this would just be result. Result is we lerp from left to right, and that's the blend factor that's being used. Okay, V-blend is like that, but we use top and bottom. Text color top, text color bottom. Blend factor is gonna be just the top ceiling minus top left. Top ceiling minus top, so text top. Okay, and we lerp this top to bottom by the blend factor. Otherwise, the result could just be anything, right? It's just we can sample whatever and use it. Yeah, why not? That one. Okay, does that compile? That compiles. Okay, what does it produce though? Let's see. Shift 4. Okay, well, it produces some interesting results. Already we are looking at very interesting results. Huh. It's like it's doing it backwards, weirdly. Okay, is there anything obvious going on? Well, I mean, we can capture the Reddit and just like take a look. Launch, no, capture, go in, and then we can just look at the thing. Like here, history, debug pixel. Okay, so text left is 1.5, text right is 2. Okay, so where is this if it's 1.5 and it's here? Text top, text bottom. Top is 1 and bottom is 1.5. Yeah, that seems correct, yeah. Left ceiling is 2, right floor is 2. Top ceiling is 1 and bottom floor is 1. So H blend is true. Okay, right floor is 2. Right floor is 2. So it's like a little not... Okay, so both of them end up being true. Okay. Well, I mean, it is kind of close to alignment there, right? So I guess that makes some sort of sense. Like text bottom, yeah, it's exactly like in the corner, sort of. It's exactly here, or (1.5, 1). 2, 1.5. Yeah, it's exactly here in the corner. And apparently we need to blend all of them. Okay, so we sample the colors. What are the colors? Well, top left is red. Top right is also red. Yeah, that makes some sense. Bottom left is red, and bottom right is also red. So all of them are the same. Okay, what does blend factor end up being? 1, 1. 1... 1... Well, is it? Hold on. Top ceiling minus text top. Well, top ceiling is 1. Wait, hold on. 1 minus 1 is 1? 0. 1, 0. No, that's fine. 1, 0. That makes some sense, yeah. So anyway, the result is gonna end up being just red color. So that seems fine. That seems correct. What's going on in this pixel though? Is it? Are we debugging this pixel? Is this correct? Okay, let's find out. All right. Text bottom top is 1, 1.5. 2.5, 2. Right, left. So now we're looking at this pixel. Huh. Okay, so left ceiling is 2. Yeah, so it's like, well, it's exactly that, right? So left ceiling ends up being 2, right floor ends up being 2, which makes it think that it's fully, I see, so it makes it kind of think that it's fully in here, but then when we sample, always something comes up with these things, huh? Okay, well, let's continue. Top ceiling is 1, and bottom floor is 1. H blends through, V blends through, okay. Okay, so we sample the colors, so top left ends up being red. It's this one being sampled. Top right ends up being blue. Yep. And then the same from bottom left is red. And bottom right is blue. Okay, so, alright. Well, if the blend factors end up being correct, so left ceiling, right, 2 minus text left, 2, 0. Top ceiling 1 minus text top 1. Okay, blend factor is a 0. Text color top. Lerps to red. Do I not understand how lerp works? First, second, linearly interpolates from X to Y. X times Y minus and what am I calculating? I'm calculating the opposite of that. Yeah, because when my blend factor is 0.9, that means you need to take the left. Okay, so all the lerps are being done backwards, essentially. Well, we could switch them. Around like that. See if that helps. Okay, well now it's not quite as egregious when it's kind of all nice and aligned. Okay, what happens when it moves around, though? Let's go launch it. Don't save. Zoom in, and we're gonna move it around. Okay, well the internal blend at least kind of works. Of course, we have the edges being a problem, but like internally I think we are blending correctly. Yeah, by the looks of it, this is fine. Alright. Except we're not checking for top bottom, of course. Okay. Where is input? Left, right, top, bottom. Let's bind some keys to top and bottom. Yeah. So up will be top and bottom here. Top, bottom. Okay, up and down. Yeah, I should probably call them up and down. Left, right, up, down. Yep, up, down, and then just in here, let's move them up and down. Input key ID up, sprite position Y, it's world position. Increase it. Down, decrease it. Alright, zoom in. Okay, so that's movement up. Okay, we're looking at the internal blend, and okay, well that does seem to be blending. And this is like, if you go to the, if you start blending all of them, which is like, okay. Yeah, that does seem to be doing the blend with the scaling just fine. Alright, let's see. Can we make this work for, like, what do actual sprites look like? This is the debug texture. Let's turn that off. So now we're gonna be looking at the actual atlas. What's this? Input. That's the atlas. That stays. that stays as is. Left, right, up, down, that stays. Sprite scale multiplier, yeah. So this toggle scaling thing, yeah, we're just not gonna do that. We're not doing that. Camera position 0. Sprite scale multiplier is just set at 2. Oh yeah. That we're not doing. Okay, what do we got? Okay, well that's, you know, those are different rectangles. We're gonna fix them at some point. Alright. So the main thing to look for here is... Okay, well, alright, so that's moving up and down. Okay, so this is like, right here is kind of almost fully aligned horizontally. This is vertically. Yeah. Okay, so we shouldn't have any weird like glitching going on at the edges. You know, things like that. Okay, well it seems to be moving fine. Okay, well if it's moving fine, can we do just arbitrary scaling? Let's see. So sprite scale multiplier, set it to 4 point like 4 or something like that. So now we can never be really aligned. Okay, so that is weird. That shouldn't be happening. Like that, although, no, it's not the edge. It's not the edge of the texture. And like, yeah, I need to turn off mirroring. And probably turn off animations. Well, yeah, so immediately you kind of see a problem. So that, yeah, there it is. There is that reason why I didn't do the blend to begin with. Like, what's going on there? It's like these pixels are included, but these bottom ones are not. I mean, the blend factor in these pixels is evidently 1, and these bottom ones it's 0. So, I mean, we can just step through that and see exactly. What's happening? Alright, so let's look at that pixel there. So it goes into what? Only the H blend. No. Okay, so it's no blend. It says no blend. So just sample the top left. Okay, and why no blend? Because if we look at text bottom, okay, so text top is 7.2, text bottom is 7, 1356, 1356. I wonder if we can actually see the input. Okay, we can. That's the working one. So I'm guessing it's like... there it is. So it's 1350. What was it? 1356. Which is here. That's this row. And that's 7 on the Y. We got 7. Oh, so yeah, so it's this pixel. But when we sample the top left, the nearest to the top left is actually the one on the left of that. So we're fully... Okay, I see. I see. So we're like over here, and we're sampling this, but the nearest ends up being that. Somehow. Even... Like, if this pixel is fully in, how could that even work? I mean, we're... it's almost though, right? It's 1356. Just about. It's like here. And the sampler thinks, well, the nearest pixel is that one, I've decided. I mean, the same problem would happen like here. The top right could sample that one instead. I mean, I guess we could use the center in that case. Yeah, we have the UV for the center, right? So instead of sampling these left-rights, what we can do is here, we want left and right, right? So here we can just use input UV Y, so that's the center UV. And here we want top and bottom, so instead of using left, we use UV X. There. Orange. Okay, well, it's still not still not great. Okay, there's all sorts of weird stuff is going on now. Like for this pixel, seven. Okay, so it's in between on top and bottom. But in terms of left and right, it's inside 1356. But again, it's like right on the edge there. It's like here, like in 1356, it's like right on the edge, and it's also like smaller, like that. It's like right here. And left ceiling is 1357, right floor is 1356, as you'd expect. So it's boom, boom. Okay, so H blend, so just do the V blend, it says. So UVX ends up being that, which is like, which should be here. So we're going to be sampling from here, and from here the nearest pixel, from the top and from the bottom. And that ends up being what? Transparent, and bottom is also transparent. So we end up with a transparent pixel. But the one right below that is that the same 750 what? 750 is it this is 751. Wait, is this 751 or is this 7? Can you show me the fucking... Can you show me the full name of this? Oh my god. 51. No, it's the same. That debug button is just so good. Yeah, alright. 1356 again, so on the X we've got that same situation. On the Y now we're fully inside a pixel. pixel 7. So we should not blend anything. No. Oh, I'm still not something the right thing here. So this should be input UV. Just sample the center. Well, render doc. Launch, no. Alright. Capture. Okay, so this actually looks right. Alright, let's move around. Oh my god. Oh, look, this is now working. Interesting. Okay, well, this looks fine. Let's make it move slower. And look for artifacts. Yeah, I mean, this seems to be working fine. Well, we'll keep it then. Alright, well, keeping it means... Yeah, this toggle scaling thing, we're not gonna be toggling scaling anymore. Now we have just arbitrary scaling that we don't really need. I mean, we've tested it that it works, right? So we don't really need an input for that. Let's remove it. Yes, so that's fine. Sprite scale multiplier. Was just setting it every frame. It will be configurable by something, so I guess we should set it at the end of the update. Or, you know, well, we should set it somewhere. I don't know if it's at the end of the update necessarily. But that's only one thing. Now we need to get rid of all the MIP stuff and separate the shaders. Where is my MIP stuff? MIP. Okay, so that is just not happening anymore. All the MIP everything goes away. So now there's only one of these. Okay, like that. And And of course these need to be 0, 1, 2. It's the Lemurian 0, 1, 2, 3, 4, 5. So Commando is 2 still, Lemurian is now 4. Yeah, that works. Sprite does not have a MIP anymore. Not that it ever did, because they're global anyway. What's going on here? Sprite entity. Okay, so we just need to add the animation ID. So we can just cast this as i32, right? And cast this as i32, not that it does anything. Okay, so it's just that. Okay, so that's how we figure out which texture in Atlas it is. Then what else do we got? Yeah, so all of this is not necessary. And sprites don't have this in them anymore. Okay, so no MIPS, no nothing. Just one set of source sprites. Alright. So the MIPS are gone, presumably. Yeah, they are. Okay, the MIPS are gone. Shaders. Okay, let's separate the shaders. So this is gonna be then, oh my god, it's gonna be a whole thing. PS input sprite and PS input screen. Which doesn't have this, and sprites don't have colors. We're not passing any colors. We're not passing any colors. Yeah, sprite and screen. Then we got PS input screen here. PS input screen. So we are not passing in this stuff. Alright, so the PS screen doesn't change. Okay, this changes to sprite. That doesn't happen anymore. And then this is PS input sprite. Then this color isn't set. PS. Okay, so this PS underscore sprite. PS input sprite. So that all works as before. And what, float for PS screen, PS input screen, input, SV target, whatever that incantation is supposed to do. Yeah. that's this. Float for result is input color times text color, return result. Right, that's it. Yeah. Well, that's the actual code. Now we need to connect them together. Okay, this is the pixel shader, this PS right here. So this is gonna be PS sprite, and then there's also a PS screen in there. Now, in the data directory, we have all these things, which we'll just delete. Okay, this should at least compile. Yeah, so at least this compiled. It won't run correctly. It does compile, okay, because we're gonna be reading ps.hl, not ps.bin. No, not in the yeah, right here. Yeah, well, this isn't really gonna work for us anymore. VS. I'm still calling it VSPS, interesting. Okay, well, let's rename this to VSPS. Okay, so that's shader VS. So now this is gonna happen as well. Shader PS. And we're gonna have to do the same sort of format here. HLSL PS underscore percent dot star s lit shader name, and this is gonna be memory scratch, arena. Does read entire file take path as the first argument? That's weird. Let's change that. Like that. Okay, so we read this shader PS thing. Okay, we read shader PS. Then we do create pixel shader device, shader PS pointer length, and then we need to store it somewhere. Well, the result is gonna have that. Gonna call it P shader, and then this is gonna be result P shader. Okay. Destroy VS is that. So this is VSPS. Oh my god, that is just not, that is not what I wanted now. Go away. Shader, P shader. What do we got here? This is just not happening anymore. P shader. P shader is not here. It's just not here. Okay, read entire file. It's another one of these. Yeah. Alright. So this needs to happen here. Context P shader. PS P shader. It's probably a better name for this VSPS thing. Okay, destroy rects. Well, that's not happening. Destroy VSPS. Yes. D3G11. Okay, so yeah, we're just gonna call this VSPS. Draw rects, pass them in. Destroy rects. I think that works. Does this work? Yeah, so that's using nearest, and there's the color, the yellow line. Okay. Let's commit that. Let's look at the to-dos actually. What? AutoGen, yeah, definitely. Implement animations, that's the next thing. Compress these two, well, yeah, I don't really know how, so that'll just hang out here. AutoGen, probably a low priority. Get sprite offsets from source art, yeah, definitely. That's after the animations. Kill focus message, yeah, only if we... yeah, that's not really a problem right now. What do we got here? Yeah, well, let's just, we added some shader compilation. Input up down, that's fine. Remove the MIPS. Read entire file, change the argument order. Just added some shader stuff. Remove that common pixel shader. Removed all MIP mapping related stuff. We don't really need that temp texture. Samplers, oh yeah, it's the same sampler now, isn't it? It's the same sampler. Okay, well then, in that case, we're just gonna pull it out. Did I just call it sampler? Yeah. Okay, so we're not going to be passing it in anymore. Oops. Yeah, so something like that. Okay, sampler is now removed. Up, down, left, right. Yeah, I mean, yeah, for now this is fine. I mean, it's not really the real update anyway. Yeah, that computation's fine. This seems fine as well. Oh yeah, we need to check that by destroying everything. Apparently not. Oh yeah, VSPS. No, not VSPS, no, it's a sampler. Okay, now we're destroying everything. Okay. A bunch of changes, new shader. Yeah. Get custom blend working. Okay. Times 16. Okay. Well, that's all for today. Thanks everyone.